Welcome to the course of Finite Element Analysis. In this class, we are going to discuss about Introduction to one-dimensional, two-dimensional and three-dimensional elements. I am Assistant Professor L. Karthik, Department of Mechanical Engineering, Hindustan College of Engineering and Technology. My email ID is karthik.mek@hiz.ac.in. So in this session, we are going to discuss about the different types of elements and its functions and how to analyze these elements. So let me briefly introduce, give an introduction about the introduction to finite element analysis. So we're going to discuss about what is finite element analysis or FEM and where this FEM is used for. Since we have different applications, so we will see one by one. And basically we are going to discuss about one-dimensional rods and two elements also. So what is finite element method and what it is? Finite element method. In general, finite element method have different descriptions, but in general, we may call it as it is a numerical method of solution or method of solving system for different kind of partial differential equations and also complex partial differential equations. So, since it is a numerical method, we may call it as an approximation technique. It reduces the partial differential equation system to a system of algebraic equation that can be solved using traditional linear algebraic technique. And since it is a numerical technique, we are going to use the matrix formulation for each and every expression or each and every structure to find the displacement, stress and strain values for the component. In simple terms, finite element method is a method for dividing up very complicated problems into small elements that can be solved in relation to each other. This term, complicated problem into small element, we may call this the named element, small element called discretization. So what is meant by discretization? So whatever the structure may be, we are going to split the structure into equal number of smaller elements and then we are going to apply the force on each and every element to find the displacement, stress, strain and other values. We are going to discuss about the overview of the finite element method. Since the finite element method has different techniques, so in generally we may call this finite element with these terms. Either it may be a strong form or a weak form. Since we have two approaches, either it may be Glarkin approach or a Rayleigh-Ritz method, and finally it would be in a matrix form. So strong form or weak form, that is approximately equal to Glarkin approach or matrix form. So what is meant by Glarkin approach and Rayleigh-Ritz method? So why use this technique and where do we use this Glarkin approach and so we will see one by one. Before that, we are going to discuss about the basic concepts of finite element analysis. So finite element analysis will be described in terms of loads, equilibrium and as well as boundary conditions. So whatever the structure you are going to apply, you try to apply a load over each and every component, and then based on the equilibrium condition, we split the elements, then the load will be equally applied on each and every part of the quad. So it is called as isotropic property. And the next one is boundary conditions. So for each and every problem, we need to define the boundary condition, then only we could be able to obtain the proper results. The next one is development of theory. In this finite element method, the different techniques are used to solve the problems, in which the majorly two methods are Glarkin-Ritz method as well as Rayleigh-Ritz method as well as Glarkin method. So what is meant by Rayleigh-Ritz method? So in this Rayleigh-Ritz method, the total potential energy is going to be minimized. Whatever the structure may be, either it may be a linear structure and defined state, you are going to apply the Rayleigh-Ritz technique to find the deformation, stress and strain. Majorly we are going to define the expression for displacements. And next one is Glarkin method. See, here also we are going to find the same thing, but here the Glarkin method is defined for and non-dimensional, non-linear problems and complicated or complex structural problems. Because the linear will be handled and carried out by Rayleigh-Ritz method. Non-linear, non-structural, complex, complicated problems will be handled by Galerkin approach. In this, both methods, we're going to generate a trial function. With the help of the trial function, we're going to eliminate the unknown parameters, and finally, we could obtain the displacement expression. But for Rayleigh-Ritz method, we know the structure. So defined structure will be analyzed. And for a Galerkin method, the structure, we don't know about the structure. Either it may be fluid, or either it may be thermal property, or either it may be a complex structure. But with the help of this technique, we're going to calculate the displacement, stress and strain and another terms. In the olden days, we have used these two approaches. After that, these two approaches will be transformed to a numerical technique called matrix formulation. Matrix formulation. Since we analyze this structures manually as well as by using softwares. Softwares like ANSYS, LSDyna, Bacchus, Cosmos. So for these softwares, we need algorithm. The equations should be converted or transformed to algorithms. Okay. So the matrix formulations are pretty much useful to find the unknown parameters. The next one is one-dimensional rod elements. Rod elements are bar elements. To understand and solve 2D and 3D problems, we must understand the basic concepts of 1D problem, because a 2D has a initial point of one-dimensional element. So for one-dimensional element, we have two nodes. For two-dimensional elements, we have the combination of one-dimensional element and another dimensional element. We will get three nodes. So once you know each and every concepts of one-dimensional element, then it is a simple term by adding the element for 2D as well as 3D problems. So we need to understand the concepts of one-dimensional problems. So analysis of one-dimensional rod elements can be done by using this about techniques, Rayleigh-Ritz method as well as the Galerkin technique, to find or to create some expression for the deformation or displacement. To solve the finite element analysis problems, the same are modified into potential energy approach as well as Galerkin approach. So it's similar to the Rayleigh-Ritz method and the Galerkin method. So we also apply this term with the potential energy approach as well as Galerkin approach. Then we need to find the displacement, stress and strain for each and every structure. So for let me talk about force. So here different kind of force are used in the materials. One is body force, traction force and point load. So body force is nothing but it's a distributed force which is acting everywhere or every part of the body. So otherwise it is called as a self weight of body. It is called as a self weight of the body. And next one is a traction force. It is also one of the distributed force, but it is acting only over the surface of the body. A few examples we may call it as frictional resistance, drag and surface shears. In fluid mechanics problems, the traction force plays a major role. And the last one is a point load, a force which is acting on any point of the element. So this is called a point load. Move on to how these elements can be splitted and how these loads can be calculated with the mathematical expressions. So based on this equation, see here, it is a one-dimensional rod. We may split the one-dimensional rod into two elements. So element number 1 and element number 2 is given. For this, how do we calculate? So these are the three major things. The first one is element strain energy. That is UE equal to 1/2 Q transverse K element into Q vector. Okay, the Q and load vector, Q is load, or K is mentioned as a stiffness matrix for each element. So the element stiffness matrix KE equal to EE AE by LE 1 minus 1 minus 1 1. So this is the basic stiffness matrix element equation for one dimensional bar elements. If you want to analyze the load vectors, so since we have different types of loads, one is body force and a traction load as well as point load. If it is a body force vector, then Ft equal to ALF by 2 1 1, and if it is a traction, then TL length of the element by 2 1 1. With the help of these expressions, we are going to calculate the element strain energy, stiffness matrix as well as load. For 2D truss element, so the combination of one dimensional elements are called as 2D elements. For 2D truss elements, so the skeleton view of a structure is called truss. For this given figure, it has 2 degrees of freedom, and the transformation we need to analyze this transformation. For once we apply a load on it, then there will be a changes. We need to analyze the transformations, and the stiffness matrix for one dimensional element is pretty changed or pretty much changed or slightly modified according to this truss element based on the transformation. And next we are going to discuss about the method of solving. How do we solve this truss elements? Since solving one dimensional problems is pretty easy than solving two dimensional problems. But it's not like it is a too complex or a super complex, but it is a simple one, but we need to understand the one. So solving the 2D truss element by using the given expressions, the direction cosines LE, the length of the element will be calculated by root of x2 minus x1 square plus y2 minus y1 whole square. Then the transformation matrix L shows that LM 0 0 0 0 LM, whereas L equal to cos theta x2 minus x1 by LE and M equal to sin theta y2 minus y1 by LE. With the help of this transformation matrix for each and every element, we are going to generate the stiffness matrix for truss. Then with the help of the truss, we are going to analyze displacement or with the help of these equations. And next one is element stiffness matrix. By adding element 1 and element 2, we will get this term KE, stiffness matrix KE equal to E, Young's modulus, area by length of the element, within the bracket L square LM minus L square minus LM, LM M square minus LM minus M square, minus L square LM minus LM, L square LM, then minus LM minus M square LM M square. So with the help of this given stiffness matrix term, since we know that L equal to cos theta, M equal to sin theta, wherever the theta is given, whenever theta is given, we are just going to apply the theta value in that equation, and finally we will get the solution, numerical solution. Then we are going to apply the terms in this term. Finally, we will get a stiffness matrix for. And how to solve this truss element? See, look at this picture. In this picture, it has different elements, different number of elements. Our number of elements are 1, 2, 3 and 4. 4 elements are given here in this truss component. See, element 1 which comprises of nodes 1 and 2, and element 2 is comprised of nodes 2 and 3, and element 3 is node 1 and 3, and element 4 is comprised of nodes 3 and 4. So first we need to name the elements as well as the noding the number of nodes. Then we are going to apply we need to calculate stiffness matrix for each and every element, element number 1, 2, 3 and 4. Then we assemble these elements in a single equation. Then the elimination approach will be three by three matrix. Okay, see, like this. 3, 5, 6, A33, A35, A36, A53, A55, A56 and A63, 65 and A66. This is what we have obtained. With the help of this elimination technique or a matrix formulation to get the element stress, element reaction force as well as displacement. So to find the element stress, how to find the element stress? With the help of this equation, sigma equal to Young's modulus by length of the element within bracket minus L minus M L into M. If you want to analyze the reaction force, it will be, the force will be applied other than the supports, then it will be obtained by using the formula called R equal to stiffness matrix into R equal to K into U or K into Q. And for a 2D truss element, we need to understand the concepts of development of table called, we need to analyze the and as well as direction cosine. Okay, what is meant by the coordinate table? See this. For each every element, there will be nodes. So we need to find the coordinate point for each and every nodal points. In this picture, node 1, 2 and 3 are given. Node 1, the distance between node 3 to node 1 is given 36 and 48. So x is 48, y is 36, and for 2 x is 0, y is 36, and for 3 x is 0, y is 0. This is the quad. And the next one is connectivity table. Connectivity, the element 1 is connected with the element 2, and what are the nodes which connects the element 1 and element 2? So for element 1, the nodes are 2 and 1, element 2 nodes are 3 and 1. And the next one is, for this we need to generate a stiffness matrix expression for each and every element. We know that for each element Lm and minus L minus Lm, Lm M minus Lm M. So we have a 4 by 2 matrix. Then assembled together we will get this 4 by 4 matrix. And the next one is the expression to calculate or find the direction cosine. Okay. So L equal to cos theta and M equal to sin theta. Since in this picture or in this structure, the theta value is not given, we literally may not take the theta value. Instead of the theta, we simply apply this equation. Length of the element equal to root of x square minus x1 the whole square plus y2 minus y1 the whole square. As well as for direction cosine, L equal to cos theta equal to, replace the term x2 minus x1 by LE, trigonometric term. Sin theta equal to y2 minus y1 by LE. So if we find L and M, then it is easy for us to analyze the L square, Lm, M square values. You just try to apply the values in this stiffness matrix equation. Next one is 3D truss stiffness matrix. Before that we saw the 2D stiffness matrix. In this case we are going to discuss about the 3D truss. Since for 3D a small term will be added the above expression. So Lm00, now here Lmn00, 00 Lmn. And for element, length of the element, Z2 plus Z2 minus Z1 the whole square is added with the existing equation. And also the direction cosine is n equal to cos pi, that is equal to Z2. And the stiffness matrix, which will be increased to 6 by 6 matrix. For 2D only 4 by 4. For 3D 6 by 6 matrix will be used to calculate for 3-dimensional elements. Let we move on to the problem, example problem, 1-dimensional rod element. Okay. So look at the problem, a problem statement which is given, which is taken from the Chandrapatla and Belagandu book. I consider a bar which is shown in figure. Then determine the following by hand section. We need to calculate displacement at point P, stress strain, element stiffness matrix, strain energy in element. These are the things we need to calculate. We look at this picture. A bar element is given. Two nodes are there, x1 and x2. A point P is given at any point of the bar. So which may be mentioned as a 20 inch. Q1 is x1 equal to 15 inch in Q1 and Q2 x2 equal to 23 inch. Since we need to calculate displacement, stress strain, element stiffness matrix as well as strain energy in element. Also we know that Young's modulus of this bar is 30 into 10 to the power of 6 psi and area equal to 1.2 inches square. So Q1 equal to 0.02 and Q2 equal to 0.025. So you're going to apply the terms. Let Q be the displacement at P. Then we have the formula, shape function formula. Q equal to N1 Q1 plus N2 Q2. In other words, U equal to N1 U1 plus N2 U2. Since we know N1 and Q1, N2 and Q2, directly we are going to apply the terms. We will get Q equal to the displacement Q equal to 0.0231 inch. With the help of this Q, we analyze the stress and the strain element, epsilon and sigma. Okay, so epsilon equal to 1 by x2 minus x1 into minus q1 plus q2. You just try to apply, you will get epsilon equal to 6.25 in 10 to the power of minus 4. And for stress, E equal to E into PQ, E value is given 13 10 to the power of 6 and PQ is 6.25 10 to the power of minus 4. Once you apply this, you will get sigma equal to 18.75 10 to the power of 3 P. And the next one is element stiffness matrix. Since for a one-dimensional element, we know that K equal to AE by L, 1 minus 1 minus 1 1. Apply all the values instead of A, E and L, you will get 4.5 in 10 to the power of 6, 1 minus 1 minus 1 1. And to find the strain energy in the equation, since we know the formula for strain energy, 1 by 2 U transpose or Q transpose K into U. You just apply the equation and values in this equation. Finally, you will get U equal to 56.25 LB inches. And the next one is what we have concluded in this session. So, from the beginning, we saw that what are one-dimensional elements and two-dimensional elements and 3D truss elements. How they analyzed one-dimensional and what are the things we calculated in the one-dimensional element, and how to define or how to calculate the two-dimensional elements and also three-dimensional truss elements we have discussed. And the another important point is good hand calculation are powerful when applied to computers. Only limited limitations are the computer limitations. See, for this finite element analysis, one-dimensional, two-dimensional and three-dimensional techniques, since we apply load on structure, either it may be one-dimensional, two-dimensional or three-dimensional, it is not at all a problem. If you want the exact solution, we need to increase the order, increase the polynomial order to get the exact solution. Otherwise, you will get the approximate solution. Thank you for class. We will discuss about some other concepts. Before that, I will let you tell me about the references for this video lecture and also for our course Finite Element Analysis. Majorly I am relying on J.N. Reddy as well as this book Chandra Bettula, Tirupati and Belagan 2, and also some concepts which will be taken from Wikipedia as well as the Alexandra Henry. Few concepts are very useful once we start reading that, and also the structural analysis in Wikipedia. Thank you for video lecture. In the next class, we will discuss about the major problems while we apply in a 2D structure or 3D structure, and how to mesh and what are the different categories of mesh that will be discussed in the next class. Thank you.